Financial Modeling, Topic 15, Option Valuation and Hedging, Section 5. We're going to compute hedged and unhedged cash flows using option and forward hedges. So let's start with the example here. We're going to have an example of hedging a euro sale with options and forwards. So suppose Apple Computers plans to earn 800 million euros in 1 year from the launch of a new iPhone in Europe. Apple's considering hedging the position with options or forwards to sell the euros. Furthermore, Apple is considering hedging less than the full amount. In other words, if it expects 800 million euros, what if it only hedges 700 million of the euros? And then lastly, we're going to, the next model I'm going to show you, we're going to estimate the expected US dollar revenue and hedged values using at-the-money puts and short forwards. So here is the model. The expected amount of the received euros is 800 million. The current spot price of the euro is $1.15 per 1 euro. The maturity is 1 year. The US interest rate is 2.5% for 1 year maturity. And let's say the European risk-free rate, which I'd probably consider the German Bund rate, their treasuries, as 1.5. From an earlier topic, when we talked about forwards, we said that the expected forward price and the expected spot price is this formula. The current spot price times 1 plus the US interest rate over 1 plus the foreign interest rate, since this is a direct quote to the 1 power. So the euro forward is 116. That should be the no arbitrage forward price. And it's also the expected spot price, $1.16. Let's say the expected volatility of the euro is 11% per year. I then value a put on 1 euro by using my Black-Scholes formula. And notice under dividend yield, I go ahead and plug in the German or European risk-free rate. So that put should be selling at 4.4 cents per put. In other words, if you pay 4.4 cents, you have the option to sell a euro at $1.15 1 year from today. I then calculate the expected appreciation of the euro. In this case, if I take the expected spot price 1 year from now over today's spot price, it tells me that the dollar is expected to appreciate by 1%. However, that means the euro is expected to depreciate by 1. I'm sorry, the euro is expected to appreciate by 1% by just taking 116 over 115 over 115. And that's 0.99% if I do it mathematically. So the euro is expected to appreciate by about 1% based on this model. I'm then going to calculate my unhedged cash flows. If I simply take 800 million euros times what the exchange rate is expected to be next year, $1.1613, I expect to get $929,064,039 for my 800 million euros. However, I'm going to simulate the spot price next year. If I take the current spot price, 115, times 1 plus that 1% increase, and then I assume that changes in the exchange rate follow a normal, are normally distributed and follow a random walk process, I'll take the current spot price of the exchange rate times 1 plus the expected appreciation plus a random z variable, that standard normal random variable, times the volatility. This is now my random walk model of exchange rates. And if I take that random walk model, notice the risk normal 0, 1 is the z variable using at risk. If I take the random exchange rate in B13 times the 800 million euros, run that 10,000 times. I'm going to run a simulation now, the at-risk simulation. I made this a risk output. I'm going to run it 10,000 times, and this shows me the histogram, or the distribution of the 10,000 US dollar revenues from the 800 million euro receivable. So you can see the 90% confidence interval looks like it's going to wind up being between about $760,000 and $1.1 million. You can see my 5% lowest revenue is $762,000. My 5% highest is $1.1 million. So this is a way of thinking about the risk of not hedging this euro receivable. That the risk is I expect 929, but I'm 90% confident that it's going to be between 762 and $1,095,000. Another way of thinking about that is if I just look at, if I made this an output and look at the 90% low or 5% lowest and highest exchange rate, I'm 90% confident the exchange rate based on this model is going to be between 95 cents and $1.37. That's what drives this 762 and $1,001,000. So say Apple's unhappy with that risk exposure, and what they want to do is they want to get a forward contract or an option contract to sell the euros at $1.16 using a put or using a forward contract. Well, let's calculate the payoff if they got, or if they bought a put on 800 million euros. What I have here is the payoff, the profit of that put. And you can see our formula. All right, this risk output is just an at-risk, at-risk formula to tell at-risk that this is an output I want to collect data on. All I do is I take B16, which is 100%, because I want to hedge 100% of their exposure, times B2, their 800 million. So what that says is my Q in my formula is going to be 800 million euros times the payoff of the put, max 0, B7, which is my strike. I'm going to get a strike equal to the expected spot. That's called an at-the-money forward put, when you set the strike equal to the forward price, minus the simulated spot price right here. So this is 800 million euros times max 0 times, or max 0 or the strike minus ST, minus B9, which is the cost of the option. That's why this is profit. So when I run this 10,000 times, every time the put devalues, say this random Z number is really low and the euro is only selling at, say, 90 cents, what's going to happen is the unhedged revenue is going to go down very far. However, every time I get a random low Z value and the euro falls, I'm going to get a big payoff on my put. Now, if you come down here to this formula, this is simply taking my unhedged revenue plus the payoff of the put. And if I run that 10,000 times, which I already did, and I browse those results, this is the results if I hedge it 10,000 times. Now you'll notice that if I hedge using this put and run my simulation of both the unhedged revenue and the put, what that does is that guarantees me I always can sell my euros at least $1.16. However, because if it is anything below $1.16, I'll exercise the option and sell all my euros at 800 million. However, if the euro does wind up being any value above the strike price, I'll get more. So what you'll notice is I haven't eliminated my risk. I've actually just kept all the good part of the risk. And let me let this finish, and what you'll see is I now have a graph showing roughly, since this is an at-the-money option, about half the time I wind up getting the 116 times the 800 million euros minus the cost of the option. The other half the time I do better than that, because those are situations where the euro actually winds up being above the strike price, and I go ahead and sell them in the spot market at that higher price. So now, with my put, I expect 893. It's a little bit lower because I had to pay for that option. However, my position now is the lowest I can get is 893. And the highest is 1,006,000. So it looks like you can see that the exposure has shrunk and I no longer have any other downside because anytime the euro is selling for 116 or less, I will get that minimum amount. If I again look at browse the results one more time and look at some of the values in here, what you'll see is not only the 5% lowest is 893, all the low values are 893. In other words, the lowest possible I can get is 893. Worst case. However, I could do much better. And then I just do another simulation here where I go ahead and simulate the profit or payoff of a short forward. So I have 100% of my 800 million, as that's my quantity, times my short forward payoff of B7. That's my, well, we'll assume that's also my forward price minus my simulated spot. When I add the payoff of a short forward on 800 million euros plus the unhedged euro position, and I run that 10,000 times and browse the results, you get a really funky graph. Look at this. Every is a histogram where every value is exactly the same number, because this company that is hedged 100% with the short forward will always get 116.13 times the 800 million. So in other words, it always gets $929 million. So when I add those two numbers together, every time the euro is low or high, it doesn't matter. I'm exercising my forward and selling them all for 929. So what you see is my worst case, my best case, my average case are all 929. So this is a different way of thinking about hedging. I can either buy a call, I'm sorry, in this case, buy a put, pay that 35 million or whatever that turns out to be for the put, retain some upside, but I've eliminated my downside. Or I could just peg it and say, I just want to guarantee 929, and I will no longer have any upside. So this is a way of modeling the use of a forward or an option to hedge a receivable. If this were a payable, say Apple had to pay 800 million next year, I would simply use a call to buy the euros or long forward to buy the euros. All I really have to do is change this to a call, change this payoff to be ST minus the strike, and this to be ST minus the forward price, and that would model a payable, and I'd also make this minus 800 million. So in this topic we talked about how to model the hedging of cash flows using forwards and options. Now I have this hedge ratio. Most companies don't hedge 100% of their exposure, mostly because there's quantity uncertainty. In other words, I'm not really sure I'm going to get 800 million. That's my best guess. So what you might do is just hedge, say, 90% of your exposure. No, in other words, when I run my simulation, I'm still assuming 800 million is my receivable. However, I only want to get a forward or an option on 90% of that, just in case that 800 million doesn't come through. In that case, what you'll notice if you rerun this, you have a little bit of risk left over here on the forward contracts because you've only hedged 90% of your exposure. The other thing that we're going to talk about is actually an assignment problem is what if they do a mixed strategy? What if they have 800 million as the expected euros, but they hedge it with 600 million using forwards and say 100 million of put options? In that case, I'd have to have two different quantities here. What I'd have to do is have a separate sell out here saying something like 700 million is the amount of my quantity of my forward, and say 100 million is my quantity of my option, and then I would just have a link here to use a quantity of 700 million and a quantity, I'm sorry, on the option was 100 million, on the forward was 700 million. And then what that would model is if Apple chose to hedge their 800 million exposure by hedging 700 million or getting a forward on 700 million and say an option on 100 million. And I also could do it this way, say 600 million. What if they don't hedge 100 million of that exposure? So in this case, I would just have the option using a quantity of 100 million and a forward using a quantity of 100 million, and that would simulate hedging only 700 million of their 800 million exposure, in which 600 million might be hedged with a forward and 100 million hedged with an option that gives them more flexibility in that quantity uncertainty. So this was computing hedged and unhedged cash flows using options and forwards.